I got really annoyed a while back watching a video on Linus Pauling that claimed he started off as a good scientist, but turned into an egoistic quack over time. I don't agree with this assessment at all. In fact, he is most certainly the most productive scientist of the 20th century, theorizing and experimenting for many, many years. In fact, I would say he is the most able American scientist of the 20th century, and possibly the entire world.
You know, my brother once told me that nothing someone says before the word but really counts. But.
Here we go. There. This thing isn't worth the gold it's made of.
I got a bit of a comment tirade from a guy claiming to be a telomere scientist the other day, saying that I was wrong about fasting and telomeres. Well, there's no such thing as a degree in fasting or a degree in telomeres. If he actually is a scientist, it's probably a microbiology degree, which only gives a keyhole view into biology and won't talk about either topic at all. Not to mention that almost everything here is very new research, so you wouldn't have been taught it in school anyway. And that's what almost everyone takes today, because that's what's useful for creating new medications, and that's where all the jobs are. So that's the only kind of biologist that we have, more or less. And that explains saying the post I made about fasting and telomeres is wrong, even though I've shown studies about it many times.
Alright! That's it! I'm fed up with you. I invite you into my house to put on a play for you, and you interrupt me? What kind of...
The thing is, it's not me claiming anything or epidemiological data. It's experimental science demonstrating that it's true. I only bring it up because I actually get persistent inquiries about telomeres. There's a lot of obsessing about telomeres, even though longevity experts don't talk about them as much as they once did. Long story short is that telomeres for most cells just don't really matter all that much, except that it may allow for quicker healing for the skin and for some other tissues. On the other hand, telomeres in stem cell pools are increased by fasting, and that actually may have an effect on longevity and will definitely help with healing the body.
Really?
So I guess I've more or less spoiled that video, but I'll redo it anyway at some point, so this topic can be put to bed once and for all. But in short, fasting helps with telomeres, but it is really stem cell health and stem cell pool size that really matters for longevity. And a lot of things are going to help with that, such as alpha-ketoglutarate, for example. People today, if they've even heard of Linus Pauling at all, think of him as the vitamin C guy. That's very unfortunate, because there have been very few people in history who have done as much as he has for science. He published several significant papers in the field of chemistry before he even graduated, and even as a freshman he was being groomed to eventually become part of academia. He would eventually go on to be the most important professor at Caltech, one of the most important technical schools of the time, and it was largely so important thanks to him and the large amounts of grant money that he drew to the school. In fact, I'd say while Einstein is a bit overrated, Pauling is amazingly underrated. Einstein could not prove his E=mc² theory, that is, the theory of relativity, and the mathematician Hilbert did so in a single weekend. Many scientists would have published first, which happens all the time, but Hilbert acknowledged it was his original idea and allowed Einstein to take all the credit. Einstein also didn't publish very many papers, far fewer than Pauling, but he happened to be in a field that was at a critical stage and had the public eye at the time, and he was a good scientist, of course. On the other hand, only nuts and bolts scientists making practical discoveries would care or even know about most of the things that Pauling did, or would likely even understand the significance. Essentially, much of his work made it easier to explain why chemicals had certain properties and why they bonded together as they did. He did a lot of work to bridge chemistry and physics together, and much of this was only proven correct decades later when computers were available to do the grunt work. This made it much easier to predict what kinds of chemical compounds were possible, as well as their likely properties, taking a lot of the trial and effort out of chemical and metallurgical science. I believe if Pauling had been interested mainly in physics and math, then he would be much more famous today, and we also might be more advanced as a society. While he is not a household name today, in spite of winning 2 Nobel Prizes, he was actually the first scientist that Oppenheimer approached when the Manhattan Project was created. He turned down this opportunity for personal reasons, and this is another reason he is obscure to the public today. Pauling didn't just randomly come across his ideas, he grew into them, but it really started because he had kidney issues due to high blood pressure. This led him to the relatively new but widely promoted DASH diet to reduce salt intake, and to eat a high-carb diet based on fruits, vegetables, and low-fat dairy. This reduced his blood pressure, which in turn relieved his kidney function problem. This was the most widely promoted science of the time, even though it has already been proven, but ignored, because it went against the food industry goals, that the real issue was metabolic syndrome, which came from carbohydrate consumption, especially fructose and sugar. While the DASH diet is one way to relieve metabolic syndrome over time, or at least keep it in check, it is much more efficient to simply lower or remove carbs in order to reduce blood pressure. This reduces insulin, and this is going to lower your blood pressure. This makes the liver healthier and allows the body to control energy metabolism properly and stop having these issues.
Even if the liver is insulin resistant, insulin can still stimulate lipogenesis. In contrast, in the insulin resistant liver, insulin is less able to make glycogen, so it's less able to tell the liver to store glucose. And this loss of stimulating glycogenesis means we have a reduction. We actually end up, insulin loses its ability to prevent the breakdown of glycogen. So now we have glycogenolysis. This event is disrupted in insulin resistance. And so now we have a liver that is supposed to be holding on to glucose. It's actually letting it go. But it's not supposed to. Remember, that's the pathology here. Insulin is trying to stimulate, or it ought to be stimulating glucose uptake and storage. It's not working anymore. So the liver doesn't get the signal not to break down glycogen, and so it does. It's not being inhibited, the glycogenolysis. And this, of course, drives up blood glucose levels. So once again, if we look at this paradigm of the progression towards full-blown type 2 diabetes, with the liver being insulin resistant, we've pushed that a little further down the road. The patient has progressed a little further towards full-blown type 2 diabetes. So they're getting this mounting hyperglycemia.
While it's true that lowering salt in the diet can lower blood pressure a bit, it is mainly insulin that drives high blood pressure. Insulin causes the body to hold on to both sodium and water, and this ultimately drives up both blood pressure and inflammation.
And it can still work quite well at the kidney level. And one of the jobs of insulin at the kidney level is to actually hold on to sodium. So that's actually a much more important factor for increasing the sodium in your body and causing high blood pressure than is the amount of sodium that you consume. If you consume a modicum of sodium but have very high insulin levels, your body's going to try very hard to hold on to all of that sodium. You can, on the other hand, consume a whole lot of sodium but have very good low insulin levels, and any excess sodium that you consume will just come out in your urine.
If you're overweight, you have to be aware that a lot of that weight actually is water in the form of inflammation. The reason that you can't drink salt water, or I should say more than minute amounts, because the Vikings actually did sip small amounts to gain moisture and to conserve their fresh water supply, is that it will increase inflammation in the brain and it will become lethal very quickly and drive you insane. So while he did get some relief for his kidneys, this was based on faulty and incomplete corporate sponsored science, which is often the case for nutrition and medical education, unfortunately. This likely biased him towards plant-based nutritional solutions in general and fueled his wild enthusiasm for vitamin C. While the idea that oxidative stress drives aging is common knowledge today, it might surprise you to know that when Pauling was young, we had no idea that superoxide radicals even existed. In fact, he was the first one who hypothesized their existence in 1931, so in reality, he could be called the first anti-aging scientist. In the 50s, he also wrote a paper talking about obesity and lifespan. While there is strong correlation to obesity and death rate, it's only a correlation. That's not to say it's all coincidence, but again, obesity is not the driving cause, but metabolic disease and type 2 diabetes, which increase blood pressure, increase inflammation, damage organs through glycation, lead to cancer, and on and on. It is easy to then leap to the conclusion that a plant-based diet of fruit and veg with some low-fat milk will increase your health. This fit in with his personal experience and also with what was being heavily promoted by the industry at the time. In reality, the real culprit here is the processed carbs that stimulate hunger and the veg oils, which are shown in direct experimental data to greatly increase mortality rates far beyond what obesity is epidemiologically correlated with. This comes from suppressed data from Ansel Keys' own experiments from long-term, high-budget, well-controlled experiments. His own data also showed cholesterol and saturated fat do not increase mortality rate whatsoever. Nonetheless, the industry and government keeps promoting the same nonsense ideas because a diet full of cheap ingredients is much more profitable than animal products, which are perishable and have a very slender profit margin. It also doesn't take into account the fact that carbohydrate metabolism is just inherently more damaging and produces more free radicals per ATP produced. In fact, it is a minimum of 66% more free radicals produced in carbohydrate metabolism, and there's no upper limit. That is, the ATP generation can actually fail in carbohydrate metabolism, and cells can even degenerate into fermenting fuel using the Warburg effect. This is dangerous not just because it drives oxidative free radicals that can damage nuclear DNA and mitochondrial DNA, but also because it can be used to create everything that a cancer cell needs to grow. In fact, fermentation like this is the ultimate source of all essential amino acids in the body, whether it comes from bacteria in the soil or bacteria from a cow's gut. Otherwise, cows would starve to death eating grass because it simply contains very little usable protein. What cows really eat are bacteria, i.e., tiny animals. This is also true of gorillas and every other herbivore. There's no such thing as a true herbivore in the sense vegans would have it, and everything eats other animals and there's just no getting around it. Even the plants do. Cancer cells also can't do this with fat, so for all the wackos constantly trying to claim that ketones can fuel cancer, it's just not true. Fat can only be burned through oxidative phosphorylation using oxygen, not fermentation. If a cancer cell does this, it's a good thing because it sends the ATP to the mitochondria, and that's the mitochondria that can cause cell apoptosis in cancer if they have the energy to do it. Cancer cells are not really alive at all. They're zombie cells, and energy is not really their main need. And even if they don't get any, they can just sit there and wait until they do. Their main need is actually building material, and the way that they produce it is through fermentation of carbs, or the Warburg effect. This creates all kinds of materials they can use for replicating themselves, and this includes both fats and proteins, and also combinations or phospholipids. And this can actually allow them to hide from the immune system because they can produce an exterior that the immune system recognizes as that as a normal cell. and that's why it can rapidly spread from a single deranged cell to an entire army.
Millions of them. Right across the world.
Linus Pauling was correct about oxidative free radicals, and was even the first one to theorize they exist, but how to combat them. In the 30s, 40s, and 50s, antioxidants were a somewhat obscure topic without lots of detailed study. For example, while glutathione was discovered in the Victorian era, it was not understood that it mattered so much for cellular metabolism. Since it is not a significant dietary component, and you can't really absorb it through the gut, there was also no obvious reason to pursue glutathione as a means of reducing oxidative stress at this time because you couldn't really eat it. In reality, diet is very important for glutathione status, and that would not have been clear at the time. Since he was born in 1901 though, and animal studies showing how important vitamin C was in animals were plentiful in the 60s and 70s, this was the obvious place to look. Most animals produce large amounts of vitamin C or ascorbic acid, and this is the main antioxidant they use to combat problems like illness in their body. Since oxidative stress and inflammation drive most chronic diseases, he used epidemiology to estimate that human disease mortality could be reduced by half if this problem were taken care of. This might actually be true if you could achieve it, and if you want to, the easiest way is to cut carbs from your diet. That's because carbohydrate metabolism drives up reactive oxygen species production by a minimum of 66% over fat burning. So you can't really reduce it by 50%, but you can reduce it by about 40%. Science is experimental, and you have to try something out to see if it works. And without that testing, it's not science. And that's why I get annoyed by a lot of people who do things like language theory and say this is where this language came from and all that, because you can't test all of that stuff. It's just all pseudoscience malarkey that may be true but could be completely wrong. Humans live a very long time, so any longevity research is very costly, and no one's willing to do this research. Definitely not the food industry or the medical industry. And the government tends to fund research that supports the profits of these industries, so any real nutritional science that costs a lot of money simply isn't going to happen in the West. Only profitable science like quack science of Ancel Keys, which actually produced data showing the opposite of what he wanted to show, is going to be funded. Not to mention safe and effective science such as the mRNA stuff, that was all funded by you, the taxpayer, not by Big Pharma. Ancel Keys' data led to the billion-dollar statin industry, and it also made trillions by promoting the processed food industry. So instead, we have to rely on limited animal experimentation. Unfortunately, no life extension was shown in rodent studies, though for some very simple animals, I think there was a little bit of increase. Shockingly though, there was a 25% lifespan reduction in some studies, and I'll talk more about why that is in a bit. By this time, Pauling was an old guy. In fact, he passed away before many of these studies even came out. If that were not the case, then he likely would have changed his mind, assuming he could overcome his vegetarian bias and his cognitive dissonance, which is always an issue when changing a long-held or very dearly held belief.
What I didn't put in the report was that, at the end, I believed that I could see 5 lights.
So why did supplementation of vitamin C cause harm in animal studies? Even if supplementation didn't work, no one expected it to actually be harmful, including me. However, there's a dark side to vitamin C. First off, all direct antioxidants like vitamin C can reduce things that they're not supposed to reduce if the levels are too high. So it's very important that the levels are very tightly controlled. Since most animals already tightly control their ascorbic acid levels, it's pointless at best to supplement and it could actually cause them harm. Vitamin C ultimately degrades to oxalate in mammals. Dietary oxalate is famous for causing kidney stones, but more and more data shows that oxalate is actually a metabolic poison with very nasty consequences for the human body. While it's true that humans typically produce about 30 milligrams of oxalate per day, this is a toxic byproduct of metabolic misfire, not a normal part of successful energy metabolism as some would present it. It's also never discussed is that is mainly a result of carbohydrate metabolism, and especially fructose metabolism in the body. If you eat a carb-free diet, or probably even just a fructose-free diet, you're going to have vastly less oxalate produced within your cells, and it's probably going to be close to zero. If you have a lot of fructose in your diet, then it could be much, much higher. While we have this data today, Pauling simply didn't have it in his time. But you might be even more surprised to learn that ascorbic acid, that is vitamin C, can actually impede your antioxidant status too. If any vegans are watching, they're probably quivering in rage by now. But once again, their futile fight against reality is foiled by scientific fact. First off, supplementing ascorbic acid lowers cytochrome C oxidase, the final step of the oxidative phosphorylation process that cleans up all the damaging byproducts. That means it pushes cells closer to the Warburg effect and lessens oxygen burning metabolism, and that's the true measure of a healthy cell, how much oxygen it can burn. If you've watched my videos about phototherapy or methylene blue, then you know this is bad, really, really bad. The video is running a bit long this week, so I'm going to have to cut it short there. The computer just can't handle editing longer videos, but I promise I'm going to have the other half out to you as soon as possible, so don't let the monkeys loose on me.
People think I got the power, because I got the monkeys. Nope. I got the power, because I'll let the monkeys loose.